Welcome to Why Not Change the World, the RPI podcast. I'm your host, Jeannie Hedden Gallagher, and on this episode, we are focusing on the brain. We'll hear from two researchers who, separately and for different reasons, are working to understand and help others understand the human brain. First up is Alicia Wolf. I recently spoke with Alicia, a senior lecturer of cognitive science in the School of Humanities, Arts, and Social Sciences at Rensselaer Polytechnic Institute, about stress and decision-making.
So I'm going to start with a completely ridiculous question, which is, why is the brain so important? I could talk to you about how the brain handles stress, how it deals with boredom, rudeness, multitasking, what your brain is doing while it's running. There is such a wide range of topics, but it all comes down to the responses in the brain. Why is it so important?
That's an interesting question. Of course, as a neuroscientist, I'm always thinking that the brain is the most important thing, right? I dedicated my life to studying it. But it's interesting because the brain is really integrating everything, right? It's integrating the outside world. It's integrating what's going on internally, right? And it's putting you in this space and time for you to do all the other cognitive processes that you do. And you do these all at once. Often in class, I talk about, hey, each week we're talking about a different process, but imagine this is not separated ever. Like, these things are always overlapping. And that's what's so incredible, that all these things are overlapping. You might be feeling something, you're thinking of the future, you're experiencing the present. Yet, generally speaking, it all makes sense to us because our brain is able to do all that.
So then how does the brain, with everything that it has going on, and all of the processes that are happening in the brain, putting it in the space that you were talking about, how does it then make decisions?
I think decision making is a really interesting process to consider. At one level, we can think about how what we call like the ancient brain is involved in decision making. And what I mean by that is our limbic system. So some of our emotional processing, the kind of brain areas that we share with other mammals. This is often where we think about the emotional processes involved in perhaps making a decision. So that's one aspect of decision making. But then we also have these higher brain structures involved in decision making, our highest brain structures. So areas right behind your forehead called the frontal lobe, specific regions in the frontal lobe are engaged in making decisions that maybe we would say are more maybe based upon logic, based upon knowing past experiences, based upon things that we've learned, based upon what we can imagine would be the consequences of certain decisions. So when you're making a decision, oftentimes you're bringing together what's going on in your body, your emotional brain, as well as your higher thinking brain. And what else is really interesting about decisions is that we make them all the time. Given that they're so frequent, just deciding what to wear, deciding what to eat, deciding bigger questions about your future, right? All of these things are happening at once. And we make so many decisions, we don't necessarily spend a lot of time on every single decision. So in some cases, we fall back on, how we've made decisions in the past. Again, this is where memory processes come up. Sometimes we fall back on, what feels right, literally at the level of your body or your limbic system, or we do some kind of combination of those things.
Why are some people better at it than others?
I think a big part of that is based upon experience. We wouldn't really argue that children are really good at making decisions, particularly ones about their future or ones that have intense kind of consequences. But this is something that's learned, right? Often when we think developmentally, younger individuals are making more decisions based upon how their body and their limbic system is responding. As we get older and we have more experiences and we've learned perhaps some of these associations between certain decisions and consequences, whether we wanted those consequences or not, we can reframe our decisions as we go through life. And at the same time, these brain areas, these higher brain areas that are involved in decision making are also developing. Those are the areas that develop last in the brain. So usually by the time we're in young adulthood, we generally are better at making decisions based upon this developmental process in the brain, based upon what we've learned in the past, based upon our ability to kind of understand how we might be responding on this emotional level as well as a more cognitive level in terms of making our decisions, and we generally get better. But then there's also always the case where there's individual differences. Some people, for reasons we don't exactly understand, are better at making decisions than others. I think it's likely related to experiences that they've had. So related to learning and memory kind of processes, as well as those connections between the higher thinking brain and the limbic system. So kind of bringing together cognitive processes as well as these more basic emotional processes in making decisions.
So I know that one of your specific areas of research has to do with stress. And well, we deal with stress all the time in our daily lives. How does stress play a role in a person's ability to make decisions?
Stress has a role in most everything that the brain does, including decision making. So, in some cases, when we have too much stress, so maybe we're feeling overwhelmed, this is associated with poor decision making. This could be that individuals feel overwhelmed even in terms of what's going on emotionally, which is often something that happens under stress, right? Changes in emotions generally towards the negative. However, when stress is going on long term, then we can imagine that those resources are going towards that stressor over many, even days, weeks, months. And then the decision making falls by the wayside. Individuals can't put as much efforts as they need to, particularly for difficult decisions where we really need those efforts. We need to feel, we need to think, we need to consider our past experiences and put that all together into making that decision. We also need to think in the future. Well, what would happen if I made this decision or another decision? Or maybe there's several decisions that individuals are faced with. So in that case, stress is interfering with the decision-making process. Really, with stress, we often think about, well, how does it relate to just general performance of the brain? Generally speaking, we need to be kind of in the sweet spot of not too much stress. This is where you're overwhelmed, you're focusing your attention on whatever's producing the stress, and you can't be focusing on other things that you need to be doing. And then too little stress, this is where we might even feel apathy, or you just don't really, are not able to focus at all because you are nearly asleep. Okay. In that case, we're also not good at making decisions, right? That's not enough stress. That's not enough brain arousal, as we call it in my field. So we're trying to be in the center there where you're able to focus, but also refocus. You're able to think in the present as well as the future and rely upon the past. And that typically happens under our normal, like moderate stress levels.
Putting it simply, does it mean you kind of need to be the Goldilocks of stress? It's like,
Yeah, basically, yeah, not too hot, not too cold. You need to be, this temperate level of stress.
that's
Exactly.
fascinating. That is just so fascinating. And
And
that
oh,
must be so hard to achieve. That must be just nearly impossible to achieve, that level, that sweet spot, as you call it.
yeah, I think it's in one way it's impossible to achieve all the time, but I think that individuals with practice and with self-awareness, knowing like where your own sweet spot is, because guess what? We all have different, curves of where we function best, what level of stress we function best, and what level pushes us to this point where we have difficulty functioning. And what level is so low that again we have difficulty functioning, but we're all completely different here. But I think that's really a main point of even focusing on well-being is finding where you're best acting and thinking and feeling, what level of stress, because stress is something we can't necessarily avoid. So I think putting resources to just avoiding stress is not necessarily good. Rather, focusing on, okay, how do I respond to stress in all these different circumstances that we find ourselves in all the time? And that's really part of life. This is something that can take years for people to learn and understand, though, really understanding your own stress level.
Yeah, I don't think anyone ever truly does. I mean,
No,
you
because life
know,
always changes. So,
exactly.
and you change. I mean, we age, things change, of course, and then the world around us changes. And that's most of the time that's out of our control. But having this as a practice where you know, could check in regularly and just note, even if you're really stressed and you can't get away from that stressor, just noting how you are at that moment will go a long way. We think about, whatever doesn't kill you makes you stronger. We have that kind of phrase that we use. But in some cases, that doesn't happen, and people are actually weakened by being exposed to some kind of trauma. And so that's what really gets me interested. I'm trying to understand, why are there these differences, particularly because stress is something we can't avoid. So how is it that some people can be resilient? In some cases, individuals seem like naturally resilient, and like that's a big question. But in other cases, individuals learn different techniques. The brain is so complex, yet it can influence not only things like neuropsychiatric illnesses or illnesses that are related to brain development in children, illnesses like Alzheimer's disease in older individuals, just to name a few. That we really need to understand these and understand this interaction between that brain health in general as well as the body's health.
Next, we'll speak to a researcher who is working to improve medical care by tapping into the brains of surgeons to evaluate and improve their abilities. My colleague Tori Wells will take it from here.
I want to introduce you to Professor Suvranu Day. He is the head of the Department of Mechanical, Aerospace, and Nuclear Engineering at Rensselaer and the director of the Center for Modeling, Simulation, and Imaging in Medicine, also at Rensselaer. Much of your work over the past decade or so has really been focused on understanding how to measure and also improve surgical training. Can you talk about some of the tools you're using and have even developed in order to do that?
Absolutely. And this is a fantastic question, because at the end of the day, surgery are now increasingly important. Intervention and endoscopy are techniques which require a high degree of technical skills. So you can think about that from the perspective of a guitarist or violinist, right? Take years and years and years of practice to be able to perform at a very high level of acuity, right? And exactly the same situation for surgeons, but they literally have to learn that art of how to perform surgery in a much shorter period of time. Imagine how long it takes for somebody to learn violin and become a master at that. So one, there is much less practice, and two is, how do we measure competence? That is a question that motivates us. So initially, we are motivated by how do we train surgeons better? And we have been developing tools, for example, like virtual reality-based tools to make that happen, right? And there are companies that have come up to provide such tools to surgeons. And simulation has now become a requirement to become a board certified in general surgery. But the question that still lingers is, what really do we measure? Right? How do we know somebody is technically proficient? So you can look at many different aspects of that. You can look at the time required to complete a surgical process. And that turns out to be a good measure, but I don't know whether I'm going to go to a surgeon who's proved himself to be the fastest surgeon in the world. I'd like to go to somebody who's methodical, who follows the steps of the surgery and does it very, very well. And then we come to this undefined definition of what is well. What does a good surgery look like, right? And the measurement of that is very, very hard, it turns out. I mean, because you're looking at a multidimensional feature of something that is nebulous. It depends upon the patient conditions, it depends upon the visual field, it depends upon the skills of the surgeon, and there's so many different factors that when we come to that becomes a challenge. So we have focused attention to understanding surgical skills directly based on the brain of the surgeon, right? Because really our central nervous system is the one that controls through the perceptive and motor skills. We are able to perceive our surroundings and are then able to learn skills. And those skills are then embedded in the brain as learned skills. Right? So this is how we have sort of evolved from just performing surgery in a simulated environment to also be able to use brain imaging. And coupled to that is artificial intelligence, where we really use AI agents to understand surgical skill performance based upon various metrics, including brain imaging.
I was actually just going to ask you about artificial intelligence. It seems that this has enabled you to expand your abilities in this area.
Absolutely. And this is so if you look at artificial intelligence, right, I mean, this is definitely, if you look all around you, in terms of the journal publication, in terms of popular media, in terms of how the world is transforming, this is definitely the age of the AI, right? But what exactly AI means to us is really collecting lots and lots of data and making sense of the data and using that sense to help surgeons become better. So that is our mission. So how do you do that? So coming back to that issue of measurement, so we can collect various kinds of data from both expert surgeons and from novice surgeons, like those that are learning. And that data can be, multimodal. It can be, kinematics. It can be visual data from videos. It can be brain imaging data. It can be skin conductance, heartbeat. It can be gaze, and so many other kinds of data. And then when you're trying to make a sense of that, you sort of create a model of trainees as well as you create a model for experts. So this was never done before because surgery has been evolving towards performance-based, meaning that when learners actually exceed a certain threshold, they're considered experts. But then what is that threshold? How do they evolve? How can we make them evolve faster? How can you make that personalized? All of these are being now answered through this massive amounts of data collection and creating sense of the data through machine learning and deep learning algorithms. So this is what, basically how we utilize the most recent advances in AI to create agents to help surgeons. These are all data-based.
And I imagine you see this as a game changer, really, in how we train and certify surgeons.
Absolutely. This is absolutely a game changer in how we train medical professionals, because it's not necessarily, it is going from this single preceptor trainee model, which has existed for the last 2,000 years, literally, that there's a group of trainees that is trained by a master surgeon and then they graduate the program. It is going from that to the collective wisdom of many. Right? AI is making the transition possible. Now, if you take that previous model, the senior surgeon has limited time right, to be able to mentor the junior people. And it is costly. It is dependent upon a lot of things, including the mood of the master surgeon, and also things like the halo effect. If I know somebody for a longer period of time, I typically tend to be biased to saying that person is doing better. Right? It is human nature, and it's very well documented. Now we are going from that model to a completely different model, which is arguably more objective, where the AI agents are actually representative of the collective wisdom of many surgeons. And they do not have a halo bias, right? They actually are providing input based upon what they observe as to how the trainees are performing. Right? So we are able now to predict what the next step the trainee is going to take in a surgical process, and then have the expert agent to provide feedback based upon whether that perceived action is good or not. So this is completely a different paradigm, and it is the most personalized that you can get.
What's most exciting to you right now about this field? And what do you think are some of the biggest potentials?
Usually the most exciting to me is really the connection with the brain. Because at the end of the day, one of the most exciting things that we've learned in the past few decades about the brain is its plasticity. That means, for example, if I'm a master violinist, it's not that I'm not, by the way, but if I were, right, my motor cortex, in certain areas of motor cortex, I would have a completely different concentration of neurons compared to somebody who is not. So this is what representation of learning is in terms of the neural connections in the brain. And that's what distinguishes a learned violinist from somebody who is just learning. So now we are bringing that science to surgeons. This is the most exciting thing that we can think about. We're bringing the research in a completely different area, right? And then we're transitioning that to understanding how surgeons behave. Right? And we can actually literally, quote unquote, see how the behavior or response in the brain actually shifts from the prefrontal cortex to the motor cortex to the supplementary motor area. So that's the connection that we are seeing that is literally changing the way that we think about surgical education and training. We really bring the science behind it. Now we can think of many strategies improving that could not be done in a brute force trial and error manner. There's many openings that are going to come up because of these understanding. One of that being neuromodulation, in which we apply stimulation directly to certain areas of the brain to accelerate this learning process. So that is tremendously exciting because, again, this whole neuroimaging area opens up the possibility of controlled neuromodulation to accelerate learning.
I want to ask you, you're the head of the Department of Mechanical, Aerospace, and Nuclear Engineering, but you're working right in the middle of the human health field. Did you imagine that this is where your path may take you when you started your research?
That's a wonderful question, Tori. I mean, I actually have thought about it through my life because you see, I mean, my research started with haptics, so which is really the human sense of touch. That is what I worked on as a graduate student working in the touch lab at MIT. Mm-hmm. And now my work has moved to the motor side of it, right? So I'm literally, in that sense, closing the sensory motor loop. And I'm really excited about it, right? I did not mean for that to be in that way, but at the end of the day, sensation is the other side of the coin as motor activity, right? So you cannot act on something without actually sensing it. And if you look at the brain pathways, they're exactly built that way. So the motor cortex and the sensory cortex are sort of tied literally at the hip, right? And so with that understanding, so I did a lot of work in the area of haptic sensation and sensing, but now we are going back to how we control our limbs and become better at something based on motor control, which is guided by sensation. So you can think about it for a robot. You have sensors and actuators. So we as humans also have the same things. And basically, we're trying to understand that and trying to make that better using technology. Both of these are mechanical, actually. If you think about sensing and haptics and actuation and motor control, both of them are very much mechanical, even though they have not ever been considered kind of a core mechanical field. But they can very well be as a very fundamental course in mechanical engineering. I mean, now I think about it more, and I realize that if we can integrate neuroscience in some of this, students will get a much better understanding of how humans behave, right? This is high time we really understand how humans behave and how the brain works. Even if I'm a mechanical engineer, even if I'm a aerospace engineer or a nuclear engineer, understanding how the brain behaves is something that is fundamental to us as humans.
This episode of Why Not Change the World was recorded remotely due to the ongoing COVID-19 pandemic. Please take a moment to rate the podcast on whatever app you're on. And if you'd like to learn more about what's happening at Rensselaer, visit rpi.edu. Thanks for listening.